and welcome back to Calero Academy. Today, we are told that there is a 4-digit integer which is divisible by 13, and the remainder corresponding to every quotient digit is always 8. List all the 4-digit integers satisfying above conditions. Well, a little mini introduction here. Well, let's understand first what the phrase statement, the remainder corresponding to every quotient digit is always 8 means. So let's explain it this way. For a quotient digit first, a quotient digit is a digit in a quotient, and so we can take an example here of 21, which is divisible by 13. 21, which is divisible by 13, you put the 1 and you minus the 13 from the 21, you have an 8. Okay. And for each one of those steps in on our 4-digit integer, which is divisible by 13, each one of those steps which gets us to 8, each one of those corresponding quotients, which is timesing and then minusing, each one of those stages is going to be 8. The remainder is going to be 8. And so that's what it means. So we are asked to list all the 4-digit integers satisfying this condition. Well, let's first identify these 4-digit integers. Let's relax constraints and think about let's think about the 4-digit integers. Well, there are 10,000 positive 4-digit integers in the world, and so there are 10,000, but we can rule out 1,000 because at 1,000 that's where our 4 digits come into hand. So we have 9,000 4-digit integers out there. Well, that is a pretty huge number. Well, we can understand that the amount of them that's divisible by 13 and has a remainder of 8. We can first know that the 10,000 divided by 13 fits roughly 770 times. So that's like 770 numbers which are divisible by 13 with a remainder of 8. Because we just take those numbers and add 8 to them, so we still have 770 numbers, and they overall divisible by 8. But that's for 10,000. Well, that's for 10,000, but for 9,000 we took a tenth of the thousand out, so it's appropriate to take a tenth of 770, which is the 77, and roughly minus that from 770, and we get 700. Now, 700 numbers is still very big, but that's why. So out of 700, we can reduce those terms using our restrictions here about the remainder corresponding to every quotient, which is always 8. We can reduce that to less than 10, or to be precisely 9. So yeah, we have found those 9, but we want to show here what those 9 numbers are that fits explicitly those terms. And so that's why we are going to now start our problem. So we have A, B, C, D. A, B, C, and D. It's a 4-digit number. It's 4-digit integers, true. And so now we're going to draw the statement A, B, C, D divided by 13 gets us to minus 2. Okay, let's solve 13. Well, we don't know. We're going to solve that later, and which is 8. So now we pull down the C. And first, before I continue on, let's mention first that there are 2 cases on how to solve this problem. First, before we start that, we have 2 cases about how. First of all, if AB is less than 13, we have to bring down the C. We have to bring down the C because we have to bring down the C. And that was our first case. And our second case is that AB is bigger than 13. And so now we don't have to bring down the C. Now, let's start with our first case, which is that AB is less than 13. Well, let's consider first that that we actually the case 2 comes first because case 1 is a bit similar, reasonable. Actually, let's start with case 1 first. Okay, so this problem, well, option 1, all options, a problem solvable by considering the constraints. So each quotient digit is less or equal to 9, and so the divisor cannot or cannot fit into the first 2 digits. That's our cases, which states that. So case 2, let's name it case 1, sorry. So let's name this clear, which is case 1 is 99, which is less or equal to AB, which is greater or equal to 13. Okay, and so that's our first case, which is AB is greater than or equal to 13. Now, for this one, we know that AB has a limited number of options, and because it has to be 8 more than a single digit multiple of 13. Like for this ABCD, we have to have a multiple of 13, but then add 8 to get the remainder. So we can have our multiples of 13 up to 91, because that wouldn't become a 2-digit number or more. So it'd be 13, 26, 39, and 52, 65, 78, and 91. So we add 8 to each of these ones to make possibilities for 8. And we get 21, 24, and 21, 30, 34, not 24, sorry. 21, 34, 47, sorry about that, 47, 60, 73, and 86, and finally 99. So this set right here is our possible solutions. Well, it definitely has to be possible solutions for AB. Well, what about C and D? Well, we'll draw the little diagram again. Forgot to write that. Oh, helps us think more. And so this minus these 2 boxes, we have a remainder of 8 for the quotient digit. We take down the C. Yes, we're gonna have the C down here, and we're gonna have to minus another 2 boxes, which is gonna get us to 8 again. We're gonna have to bring down the D. Again, which is for case 1, which is that AB is greater than 13. We switched it, and so it's gonna be AD, and we're gonna minus this another 2 boxes, which gets us to finally 8. Now, what about A, C, and D? So we know that C and D have to be 6, because 13 times the 6 lots of the 13 here gets us to 78, which is the closest multiple of 13 that is close to 8C. 8, which is A6. So now we know that C and D must be 6. So we can change, so we know that C equals 6 and D equals 6. Okay. So now our possible solutions for case 1, AB is greater than 13, greater or equal to 13, is 2,166, 2,466, and so on until our 9966. Okay. Now, case 2. Case 2 is that our AB is less than 13. Now, for our AB that is less than 13, we're going to have to pull down the C. And so we seek ABC to be 8 more than a single digit multiplied of 13. Well, stop for a minute. Let's ask yourself, same rules for both. Single digit multiple of 13. Well, we know it can't be 91 again because that's not a 3-digit number. So it has to be 104, 117. Well, that's 8 and 9 lots of 13. Well, why can't it be 10 lots of 13? 130. Why can't it be 130? Well, it can't be 130 is because remember, we have a single quotient digit and it has to be equal or less to 9 because it can't be 10, otherwise it's not a 1-digit number, it's a 2-digit number, and that's not what our case is today. So this limits down to us very easily to 104 and 117, which is 8, 13, and 9 lots of 13. And so we can add 8 to them as 4 to get the remainder. So we have to get the remainder. We get 112 and 125. Now D is equal to 6 for similar reasons related to case 1. So there's only a few amounts here. So our thing here for case 2 is 1126. In other words, 1126 and 1256. And so now looking at before so now we just figured out the possible digits for the 4-digit integer, which is divisible by 13, and the remainder corresponding to every quotient digit is always 8. And now, so our possible, well, definitely, all options for this thing that satisfies is 2,166, 2,466, 3,766, 6,066, 7,366, 8,666, 9,966, 1,126, and 1,256. Well, we've just solved it. Well, it may seem hard first, but you just need to open up a couple facts. Well, and thank you once again for watching this Calero Academy video. And this is pretty much basic arithmetic, but you have to get a sense, the notion of this problem. So thank you for watching this Calero Academy video, and we hope you stay tuned, all of you, guests, audience, and the rest of you. We hope you stay tuned for more Calero Academy videos. Once again, thank you for watching this Calero Academy video.